All right, this lesson is for Math 1, lesson 3.3 on proportions. And I do have some warm-up problems. There are 5 problems here, so I want you to go ahead and evaluate this expression, solve this equation, find the answer to this division problem. You can use your calculator for that. That does not have to be done by hand. And then here's a percent problem, so go ahead and solve that one. I do want to tell you that this says that the class of 24 has about an 85% attendance. So you are not going to get a nice, neat answer. You're going to get a decimal value that you're going to have to round because it's not exactly 85%. It's about that. So this about is going to indicate that. Okay, you're going to probably have to round. And then the last thing I want you to do here is measure the pieces you need to measure to find the area of this figure. It is a rectangle, and it is half a circle. So you want to refer to your notes for formulas for area, because you do have area of a rectangle in your notes and area of a circle. But remember, this is half a circle, so you'd find it as the area of a circle and then cut it in half. All right, so go ahead and pause and work those problems. If you get stuck on this last one, just do the best you can. We are going to go over all of these, obviously. So when you're done, unpause. Right, so hopefully we've worked through these problems. We're going to go and start with their order of operation. Parentheses. Well, there is a parenthesis, but there's nothing to simplify. So we're done with that step. Exponents. Nope, no exponents. Multiplication, division. There's multiplication going on right here. 5 times 7, which is 35. I'm going to bring down the minus. I'm going to bring down the negative 3. Do I need a parenthesis here? Well, if I put a parenthesis around 35, does it change this? No, it's still negative 3 minus 35. So it's not wrong to put the parenthesis there, but it's also not needed. And that's kind of your guide. If you put a parenthesis there and it changes the math that's happening, then you need that parenthesis. If you put a parenthesis there and it doesn't change it, then you don't need it. All right, so is this an alliance or a war? Looks like an alliance to me. It's an alliance of negatives, right? They're both negative. You have negative 3 and negative 35 to give you a negative 38. And don't forget, you can always run these through your calculator to confirm your answer. Now we're going to do solving. So that is flip, combine, divide, right? Those are the steps that we've been using. And so the first question is, what are we going to flip? Bring down my equal sign. Well, our goal is we want the number terms on one side and the variable term with the x on the other side. So it makes the most sense to take this 5 and flip it over here with the 11. So my 11 stays there. When the 5 flips, anytime we flip, remember we're turning tiles over. So this positive 5 becomes negative 5. And then please remember, you have a negative 2x in the front. Don't forget that negative is still there. This does not go away. We haven't flipped it, we're just bringing it down. Here, this is a war, positive wins, we get 6. So we did our combining by fighting a war. And then our last step is divide. What do we divide by? You always divide by whatever's in front of x. So we'll draw our fraction bars, and we'll divide by negative 2, because negative 2 is what's in front of the x. These reduce down to 0, you're left with an x. Reduce down to 1, so you're just left with 1x. And then 6 divided by negative 2 is negative 3. So that is our answer. Just as a reminder, you can always come back and plug in to make sure that your answer is correct. So we had negative 2, so negative 2 parenthesis, negative 3 plus 5. So that's our equation when we plug in our answer here, and we should get 11, and we do, so we know that answer is correct. Now this one is the one where you can use your calculator. And so remember, you can use second, and then the fraction key allows you to put in a mixed number. And the key right next to it, that allows you to convert improper to mixed. I'm going to do these by hand. So 8 and 5/4. Once again, I like to think of fractions as pizza. So you have one pizza you have 4/5 of a pizza. So the pizza's cut into 5 slices, but you only have 4 left. Now, how many slices would these 8 pizzas have? These are 8 full pizzas. They are sliced into 5 slices, just like this fraction. How many total slices are there from the 8 pizzas? Well, 5 times 8 is 40. So there's 40 slices from the 8 pizzas, and there's 4 more here on this 4/5 one. So you really wind up with 44 out of 5. So once again, 40 of this is from the 8 full pizzas, and then the other 4 is from the partial pizza. Divided by, now our pizza has 3 slices. This one has 2 slices left. This is still a full pizza. It has all 3 slices. So this has 3 slices plus 2 more. That is 5/3. So we have now converted them to improper. We will copy dot flop because that's how we divide fractions. So 44/5, that's our copy. This division becomes a dot, meaning multiplication. That's your dot. And then flop means flip the second fraction only. You don't flip the first one, just the second. And now let's multiply. We'll multiply the bottoms. That gives us 25. And we'll multiply the tops. That gives us 132. Our last step is to convert this back into a mixed number. And so, once again, your calculators can do that. I'm going to do this by hand. How many 25s are there in 132? So if I go 25, 50, 75, 100, 125, there's 5 5s in 132. So 5 is your whole number out front. Your denominator does not change. So once again, I'm just going to write what I did here. So 25, if I add another 25, that's 50, and add another one, that's 75, that's 100, that's 125. I can't go to 150 because then that's too many. So if we think about this, if a full pizza has 25 slices, that's 1 pizza, 2 pizzas, 3 pizzas, 4 pizzas, 5 pizzas. And then how many are left over? Well, 25 to 32, that's 7 more pieces. So you have 5 full pizzas with 25 slices each, and then another pizza that has 7 pieces left. Class of 24 students has about 85% of students in attendance. So all we're going to do is we're going to take our 24, we're going to multiply it by 0.85, or you could do 85/100 if you're doing the fraction form. 24 times 0.85. That means there's going to be 20.4 students, but we can't have 0.4. So is this closer to 20 or 21? It's closer to 20, so it's 20 students. All right. Now we're going to take a look at this problem here where we're going to be doing some measuring. So the first thing you need to do is measure this side and this side. So hopefully you have those measured. I'm going to do mine real quick just to confirm. What I'm seeing here is 7.8. Right, that's what it looks like there to me. So 7.8 centimeters. And then if I measure this side, sorry, I'm trying to get that. You know what? I find it's easier to not measure over the gray portion. So if I stay where the background isn't shaded or doesn't have lines, go. So I would say this is 5.8. I think 5.9 is past it. So this side will be 5.8 centimeters. So we have these two measurements. Let's first find the area of this rectangle. So area of a rectangle is simply base times height. We did length and width as well, but I like base and height better. And these are your base and height. Those are the measurements we just did. So all we have to do is 7.8 times 5.8. That is definitely a calculator moment. That is 45.24. That is the area of the rectangle. The units are centimeters squared. And just a reminder, that means about 45 square centimeters will fit into this area. That's really what we're asking when we do that. Right, what about the circle? Now I know it's a half circle, we'll worry about that in a second. But circle is pi times radius squared. Now we had talked about how pi, we're going to use 3.14 for pi, but what would the radius be? Well, if we look at this, the radius is from the center of the circle to the edge. So the radius should be somewhere here in the middle. And if this entire length is the same as this one, it's 5.8, then the radius should be half of this. So you can have a radius going this way. You could also draw the radius kind of off to the side going through the edge. It's the same all the way around. And so if we take 5.8 and we cut it in half, we get 2.9 centimeters. So 2.9 is going to be the radius. So now we can go ahead and plug in our values. We'll put 3.14 in for pi, and we will put 2.9 in for the radius. And remember, 2.9 is squared. And then we'll let our calculator do the work. 3.14, parenthesis 2.9, parenthesis, and we are squaring the second one. Hit enter, and we get 26.4074. Now remember, this is a full circle. We don't have a full circle. We have half a circle. So we're going to have to cut this answer in half. So to do that, we just divide by 2. 13. So half a circle, that's my circle. Put the dot in the center for the center, right? So this half a circle would be 13.2 and a bunch of other numbers, right? I'm going to just go 2 centimeters squared because our measurements were only one decimal place. So it makes sense that our final answers here should be 1 decimal place. So to find the total area, we're going to do the rectangle plus the half circle. So the rectangle was 45.2. I'm going to drop the 4. It's closer to the 4.2 than it is 4.3. And then the half circle is 13.2. And we'll add those together. That is 0.4. That's 8. 58 centimeters squared. That would be the total area for all of this shaded area here. Sorry, I need to scoop that up. All right, so that concludes the first page of lesson 3.3. Those are just review questions. We're going to continue doing a lot of these each day so that we can get practice and feel real comfortable with these type of problems, because this is a lot of what we're going to see on the final. So we're going to be, for the next 2 weeks, we're going to be doing warm-up problems like this. All right, so please go ahead and continue on to the next lesson.